Okay, ladies and gentlemen, it is 4 o'clock Eastern Time on a Tuesday, which means once again it's time for the briefing room. Yes, indeed. My name is Eric Cavanaugh. I will be your host and moderator for the second to last briefing room of 2015. Time flies when you're having fun, folks. Let's go ahead and dive right in. The topic today you can see is Tectonic Shift, a new foundation for the data-driven business. There is a slide about yours truly, and enough about me. The mission here, of course, is to reveal the essential characteristics of enterprise software. These days, we're going to focus all the way down on the database level and really dig into the weeds to understand what's going on in the database revolution today. So we do different topics every month. This month is an innovators topic, so it's kind of a catch-all. Cloud is next month, analytics in February. So let's talk about the importance for a strong foundation. Of course, there is one of my favorite cities, San Francisco. You know, the fact is that these days there is so much pressure on information systems, especially for data-driven companies, especially for companies that live in the cloud, whether they are online retailers or ad markets or banks or social media companies or whatever the case may be. Any company that is really relying on data for its lifeblood needs to have the proper foundation if they're going to succeed. Without the proper foundation, you wind up with serious issues when those earthquakes come your way, and those happen these days. Disruptions are quite common out there in the World Wide Web, especially traffic spikes. If you're unable to deal with traffic spikes, that can be a huge problem for your business, for your reputation, and it's something you really, really need to avoid. So the fact is that database choice these days is really important. 10, 15 years ago, there were not that many options. There were actually some column-oriented databases back then and some pretty interesting object-oriented databases. But really, most of the databases you ran into were relational in nature, and there were a handful of vendors that built them. Well, these days, there is an absolute explosion of database types out there, and there's a reason for that. And the reason is because there is a need for that much diversity. So these days, you have lots of different options for what you're going to use with your database technology, but it's really important to make the right choice. So how do you do that? Well, what's the business driver? Figure out what it is that is going to make your business hum and thrive and focus on that. And today we're going to talk about a very interesting database that is extremely high-powered and very scalable. So we've got our very own Dr. Robin Bloor in the analyst seat today. He's calling in from Austin, Texas. And we have Aerospike. It's a distributed NoSQL in-memory database. You can see it's a key value store. It is flash optimized with a hybrid RAM SSD architecture. So these folks have really focused on preparing companies that have that tremendous need for tremendous scale in their business. So we have a couple people online today. We'll be hearing from Peter Goldmacher first, and also from Alvin Richards, VP of Product over at Aerospike. There's a picture of Peter. And with that, I'm going to push the next slide and hand the keys over to the folks at Aerospike. Take it away. The floor is yours.
Hey, great. Good afternoon, everyone. Eric, thanks for that great introduction. What I'd like to do is walk you through a few slides, talk a little bit about the market opportunity, what's changed in the market, and why Aerospike exists, and what we think we do that's different than everyone else. I think the best way to do that is if I can just take a second and walk you guys through what I believe to be the evolution of data and databases. So if you go back to 1970, it was a world of hierarchical databases, and the big innovation was the introduction of relational databases, and I think everybody associates Oracle with the relational database movement. What was interesting about relational databases was they were much faster and much easier to manipulate than hierarchical databases. And if you were building an application where you knew exactly what your application was and what you wanted it to do, you could build your database underneath it so that you would tightly couple the application and the database to get the results you wanted. As we move forward through the 90s and in the 2000s, what we start to see is the rise of open source databases and NoSQL databases. And the opportunity here is that the nature of data has changed with the onset of the internet. So prior to 2000-ish, almost all data, when we said data, we were talking about business data. We're talking about HR data, accounting data, supply chain data, stuff that was very well understood and very easy to quantify. But with the onset of the internet, the nature of data started to change dramatically. So what we start to see is a whole new crop of databases come up, and the database really changes from a product to a category. And if you go back about 5 or 6 years, you start to see the emergence of open source data warehouses like the Hadoop, Apache project, and you start to see the emergence of MongoDB, which is a document database, and Cassandra, which is a key value store. And what all of these players were trying to do is they were saying, look, we think that there's an opportunity here to build a product that's more contemporary, that can handle more unique and different data sets than what the relational guys are used to doing, and we think we can do it more cheaply. So from 2010 to 2015 is really the rise of these NoSQL databases, and part of the reason for their ascent is that they're open source. So they're more appropriate for a wider variety of use cases, and the barriers to adoption are extremely low because all you have to do is download it and play around with it, and if it works, maybe you buy it, maybe you don't. And it's one of the challenges all open source vendors face is how do we convert users, of which there are many more users than there are customers, into actual customers. The other opportunity that arose with all these new databases is the database is no longer an inhibitor. It's now an enabler. Typically, if you were building an application and you wanted to do something really new and unique in the application, you were limited if your only option for a database was a relational database. So if you think back upon your own application history and the things you used to use back in 2000 relative to the things you used in 2010, and then even the things you use in 2015, the nature of applications changed dramatically. So the database has really helped catalyze the applications. And this is an important point because when you're building an application, you've got to make sure you're picking the right database for your application. And this task is compounded, the complexity of this task is compounded by the reality that if you go to DB Engines, there are over 250 databases on the market today. So if I can go to the next slide, I want to talk a little bit about Aerospike's approach to the market. So the majority of the databases that you'll see in the market today have chosen breadth of product over depth of product. And what they're trying to do is they're trying to build out a database that can handle many different kinds of application workloads. So you typically don't have the depth of functionality in any one feature area, but you do have a database that is good enough for a lot of different things. And this is really creating an interesting dynamic in the market because a lot of the better known NoSQL databases like MongoDB or like Cassandra or like Couch, the names that a lot of folks know, these guys have gone to market against Oracle, and I wouldn't say they've explicitly replaced Oracle workloads, but incremental workloads that would have normally gone to Oracle are now being deployed on these kinds of databases. So these guys are actually having quite a deflationary impact on the database market. So if I'm an Oracle customer and I'm trying to renew my Oracle license and I'm looking at the cost relative to the applications I'm building, all of a sudden a lot of these NoSQL databases seem pretty attractive to me, and that's great for the space because that validates the whole concept of NoSQL, it validates the concept of open source, and it really moves the ball down the field for everybody in the market. Our strategy is a little bit different. Rather than try and be many things to many people, we've focused exclusively on speed at scale. And that's our tagline, and that's our rallying cry. And what we mean by that is every investment we make in our product is going to either improve speed or improve scale. And this is a critical differentiator for us, and it really gives us an opportunity to go after a market that is emerging. And I'll walk you through some use cases in a minute, but if I can just go to the next slide. The importance of the database is profound. If you look at some of the earliest big data companies, Google, Twitter, LinkedIn, Facebook, all of these companies have one thing in common, and the one thing in common is they are data companies. What they've said is, if you give me a data set and you let me curate it and you let me own it and you let me manipulate it, I will monetize it. The other thing these guys all have in common is they built their own databases. So these companies all have hundreds of engineers that work in-house that only work on the database to continue to help the product evolve. At Aerospike, we understand that not everybody can afford a $25 million engineering organization just to build a database. So we look at Aerospike as a commercial version of the database that a lot of the most forward-thinking big data companies have supporting their businesses. Let me stop talking about technology and let me talk a little bit about some of our customers, because I think the use case really helps drive the point home. The first category that Aerospike was really successful in was in ad tech. Ad tech, as we know it today, simply didn't exist 10 years ago. Ad tech is all about, if I am an ad tech company, I want to make sure that I can serve somebody on the internet the right ad at the right time that is relevant to them so they will click on it and convert. And that is their entire business. This is very different from random banner ads we used to get back in 2000. So all these ad tech companies set about building supremely complicated algorithms that said, if you give me this person and they exhibit this behavior along this timeline, then show them this ad. And they all have an extremely tight time-based SLA of about 10 milliseconds to take in an enormous amount of data and serve the right ad. The biggest barrier to their success was a database that was big enough to take in two enormous data sets. One data set is the individual's profile, and the other data set is, what is that person doing on the internet right now? So when the first ad tech company, our first customer, bought the product, what they experienced was the reality that they could take an analytic workload out of Hadoop and populate their database with 1 billion profiles for 1 billion users. And then, over the course of the day, they could match web activity with that user so that as that user indicated what he was interested in that day, they could match that with the profile and serve relevant banner ads. So in your own experience, keep an eye out for this. The ads you get at the beginning of the day will be less relevant than the ads you get at the end of the day, because if you log on in the morning, they'll serve you an ad that matches your profile. But if during the course of the day you go to the Nike website and the Adidas website and the Puma website, then the ad tech company knows, okay, here's a guy, we know his profile, we know he's athletically minded, but now we know he's ready to make a purchase. So they can serve you an ad for Big 5 Sports or Modell's or Dick's, whatever the sporting goods retailer in your area is. And that will have a higher probability of a click-through than an ad just based on your profile. And that is the best example we have of speed at scale. We are the largest database in ad tech that isn't Google and isn't Facebook, and we're pretty proud of that. Let me go to the next slide and talk a little bit about our users. Our users all have the following requirements. We run, 100% of our users run our database in mission-critical applications. And this is a pretty important point. We're not a product catalog database. We're not a content management database. We are a database that is directly supporting revenue. If our database is down for our ad tech clients and they're not able to serve ads, they don't make money. And that is also true for our clients in fraud. It's also true for our clients in telecom billing. 100% of our customers use our database in mission-critical apps. Let me give you another story I think that makes the point and maybe you can relate to more than a ad tech story. So we are the database that supports a fraud algorithm for one of the biggest electronics electronic payment providers in the world. And all fraud applications in the electronic payments world have one thing in common. They've got to return a value in less than 3/4 of a second. And they have 3/4 of a second to say whether or not this transaction is valid or invalid and make that decision. Because they only have 3/4 of a second, and because they've historically run on traditional databases that are significantly slower, they've only been able to ask a tiny subset of the questions they'd love to know about the user before they return a value. So if you go try and make a payment with your electronic payment provider, the things they ask are you current on your bill? Are you over your credit limit? Is this a vendor you've done business with before? Is this within 15 miles of your home? And if those basic and rudimentary questions come back in the affirmative, the charge is approved. And if it doesn't, the charge gets declined. And that leads to two problems for the payment provider. One is a false negative. If I actually declined a charge that I should have approved that's valid, I lose out on revenue. That's money that's taken right off my bottom line. The second and arguably larger issue is I make a customer unhappy. And there are many, many, many other electronic payment providers out there. And if I'm keeping money off my P&L and I'm upsetting my customers, then that fraud algorithm just doesn't work. So for this customer, this was actually a big win for us. We replaced a legacy database. And because our database can hold so much data and is so fast, this electronics payments provider could now write a fraud algorithm that was much more robust, asked much more interesting questions on a much larger data set, and returned much more accurate answers. So profitability was better and customer satisfaction was better. So they're not only asking questions like, are you current on your spending? Are you over your credit limit? But they could also ask things like, is this person doing business with a vendor I know and trust? Is this person executing this transaction from a device I know and trust? Is there anything in this person's credit card history that would indicate that this charge is valid or invalid? So my favorite example is you get on a plane, you take an international flight, you land at Heathrow, you try and swipe a cup of coffee, swipe your credit card to buy a cup of coffee, and it gets denied, even though you bought that plane ticket on that credit card. Well, this fraud algorithm supported by our database can ask those questions. So for fraud, it's a really, really wonderful use case that displays the robustness of our product and how it directly impacts customers' businesses. So I've talked over some of the mission-critical apps that we use, and we've talked a little bit about one of our key differentiating features, which is all of our customers need response times measured in milliseconds, and they also deal with extremely large data sets, 50 terabytes. We have a couple customers in production with 50 terabyte data sets. We have one in production going to 200 terabytes, which is enormous, and it's the database is fast enough to support these sophisticated and robust decision algorithms. The other thing we don't talk about explicitly or in our first breath is tremendous total cost of ownership advantages. I'm going to let Alvin talk in a minute, Alvin, our VP of product, talk in a minute about how we actually deliver speed at scale. But our product was architected so that our customers could use fewer servers, so that you spend less on hardware, which means you spend less on engineers to support that hardware. And we've had, while not all use cases are 90% savings, we don't have any use cases that are anything less than 50% savings. So we don't lead with TCO, but it's a nice bonus when you realize that the database is valid for your workload. This next slide is just an example. It's a nice graphic to show. This was a competition we won against another NoSQL vendor where the customer had originally bought this other company's product, and then we came in and demonstrated equivalent performance at 1/10 of the cost. Just to give you a quick snapshot of our current customer base, we dominate ad tech, and we're making strong inroads into financial services and telecom. We also have great use cases in e-commerce and gaming. And every once in a while, someone just shows up on our lead mechanisms like Kayak or AmerisourceBergen, and we're able to make them customers. So we're not exclusively ad tech, financial services, and telecom. But if you have a chance to look at the product and poke around and listen to Alvin, who's going to speak next, you'll know pretty quickly whether or not we're the database for you. So let me just turn it over to Alvin.
Okay, thanks, Peter. Let me talk a little bit about how we do this. So Peter has talked about the use cases and why this technology is being adopted by those different kind of segments and those different kind of verticals. Let me talk a little bit about internally how we work. So this first slide really kind of talks about some of the internals of how the product works, and then correlate that to how does that actually measure. So essentially, Aerospike is a Flash-optimized database. Our kind of knowledge 7 years or so ago was that the way that the memory market was going to go, that whilst Flash in those days was not very well adopted and it was not particularly performant, it had characteristics that looked like it would be game-changing in terms of data retrieval and data access. Some of the challenges that Flash had in those days were its inability to deal with writes that were of different sizes. It had various kind of wear characteristics that gave non-uniform response times. And so a lot of the basic foundations of Aerospike is to ensure that not only do we use the Flash array in an optimal fashion, but we can sustain that throughput and that latency over a large period of time, irregardless of how that Flash is aging. And so essentially we do this internally by being able to accept records, and essentially Aerospike is a key value store. So with a primary key, we take that data and the value, and what we can do is then we can marshal that through DRAM or through to Flash to ensure the guarantees about availability and consistency. And we'll talk a little bit later how we scale that. The key thing about this architecture is that we are essentially in control of the whole I/O path, which means that we're not relying on the operating system or the file system in order to marshal those reads and writes from us. And that's allowed us to do a whole bunch of specific optimizations for the way those devices work. And that gives us a significant advantage over, for example, a system that's using standard operating system flushing or memory map files or any of those other normal mechanisms that databases use. And this is why we talk about it as being Flash optimized. Now, as you can see on the right, the proof of the pudding is generally in the eating, and I like puddings and pies. And so the right-hand side kind of shows the effect of being able to make these design choices. And as you can see, the charts that we have on the right are essentially a standard YCSB benchmark. This was executed by a third party called Thumbtack. These results are available that you can actually go and have a look yourself. But essentially this shows how we can deal with mixed workloads. They don't have to be write heavy or read heavy. We can deal with mixed workloads. We can also deal that with maintaining the kind of latency windows that are absolutely critically important for building these style of applications. When you're trying to make real-time decisions on data, you need to have guarantees about what that latency and that round trip from your application to the database and back again in order to provide a consistent user experience or a consistent bidding time or a consistent response time for the flow of your use case. So that's kind of how we achieve the speed. Let's talk a little bit about how we achieve the scale, because anybody can build an awesome product that works on a single node as long as you throw enough hardware at it. And sure, you can do that, but in the modern day computing architectures, clearly you want to take advantage of being able to scale horizontally, be able to build clusters from smaller constituent parts, and trying to do this in a cost-effective way. You know, you can buy a terabyte of RAM for about $20,000. Well, trying to put your entire data set, when it gets above, 10, 20, 30 terabytes, becomes very cost-effective. And so, going along the lines of what Peter was saying earlier, essentially this technology gives you better access to the data at a lower cost, which means that you've opened up a series of applications that were perhaps cost prohibitive to build in the past. So how do we achieve this scale? Essentially, as the write is coming into Aerospike, what we do is we build a hash based on the primary key. And we use a standard hashing algorithm called RIPE-MD160. And essentially that gives us a 64-bit value, which we can then determine the location of this particular record across the cluster. And so this gives us a very concrete and direct access, irregardless of the size of the cluster. We have language clients for all the standard languages you care about, C++, Java, C#, Python, Node, etc. And we have smart clients for each one of those languages which deal with the routing of your request from the application to the correct part of the cluster. And essentially what this means is as you add nodes in, we can automatically relocate and rebalance the cluster, and the clients take into effect. So your client code doesn't care about the size or the topology of the cluster. From an operational point of view, this means you can add and remove nodes, and you can do that without taking a system downtime. And as your data patterns change over time, we can redistribute the data. And this is a key thing, and the diagram on the right-hand side shows you the kind of real-world implications of this architecture. So as you can see, we've got three databases running in parallel. They're running a standard YCSB benchmark. And what happens when you take nodes down, nodes join the cluster, and so on and so forth. For Aerospike, the key thing is to under those circumstances of the topology of your cluster changing, you're losing hardware, perhaps you're losing a data center, to maintain those guarantees for throughput and latency. So as you can see, as we lose nodes, some of the other databases out there have long election cycles where they'll wait until they kind of try and figure out what needs to be done. In Aerospike, we continue to serve traffic for reads and writes as that cluster is going through its reconfiguration. Clearly, as you grow a cluster, you've gone from 5 nodes to 6 nodes. Well, you've got that 6th node that starts off by having no traffic. And so one of the key aspects of Aerospike is that we continue to redistribute data around the cluster to utilize all the compute that's available. So what you'll see is as we redistribute that data, there is some elongation of some of those response times and some throughput, but after redistribution has occurred, then we get back to the same point we were previously. And this is a key aspect for our customers, which is they don't want to staff operational teams of tens of people in order to keep this infrastructure up and running. They want to essentially treat this as lights off. They need the auto-discovery and the auto-healing capabilities in order to ensure that the infrastructure keeps on running 24/7. And one of my favorite quotes for this was one of our ad tech customers. They're in a sort of meeting with financial services people, and the financial services guys are talking about their trading days. And the ad tech guy went, well, that's kind of really interesting. It's kind of quaint you have a trading day, because when we're serving ads, we have to do that 24/7, 365. We always have to be serving. We always have to be in the position to make a trade. And without Aerospike, they would not be in a position to actually do that. Okay, Peter.
Great. So, Alvin, that was great. I understood almost nothing you said, but you said it great, so I'm sure everyone on the line understood. I want to tell you guys one more use case, and then I want to hand the call over to Robin. You'll all be getting a copy of the slides, and all the use cases are in detail on the slide, but I'm not going to walk you through all of them. But one more use case I want to talk to you about is Alcatel-Lucent. Alcatel-Lucent is a big telecom provider. They sell software to customers like Verizon and AT&T. And the interesting use case for Alcatel-Lucent was they have, when you as a cell phone customer are about to go over your data limit, you'll usually get a text from your provider that says, hey, Peter, you're about to go over your data limit. Do you want to buy another gig for $15? So you buy that gig for $15 because you don't want to pay the penalty, but you realize that your billing cycle was going to be over in a day and you only use 50 meg, and you're annoyed. So does Alcatel-Lucent, through its products, are they trying to maximize revenue from you at every turn? They're not. The challenge is, because the data sets are so large now that these telecom providers are working with, there were two separate applications. One is your data usage application, and one is your billing application. So the data sets were too big, and the data was coming in too fast. These companies have no way to know, previously had no way to know that you were at the end of your billing cycle. They didn't know, they weren't able to calculate the rate plan you were on quickly enough. So Alcatel-Lucent has a new app. And the application, it's one application that's basically replacing your billing and your usage application, combining it into one. And the opportunity there is, if you are about to go over your data usage, they can send you a text that says, hey, Peter, you've got 1 day left in your billing cycle. We think that you're going to go over by, if we trend your historicals, we think you're going to go over by about 50 meg. Would you like to buy 100 meg for $2? So even though the telecom provider is giving up that 13 bucks by selling you the extra gig, what they're doing is they're creating a better customer experience, and in so doing, they're able to reduce their churn. And I can assure you that maximizing $15 in 1 month doesn't compare to keeping me happy as a customer for another month where I'm paying $150. So we've walked through a number of use cases. Some are new use cases like ad tech, and some are old new use cases where there's a better way to do things that you've been doing historically. So just quickly to recap, we're speed at scale. We're not just speed. We're not just scale. We're speed at scale. And we think we have a product that's going to enable application developers to really write a whole new category of applications that can take advantage of all the data that's being created and take advantage of it quickly. So with that, let me turn it over to Robin.
And I'll hand you the keys. Hold on. All right, Robin, take it away.
Okay, I have the keys. So what I figured I would talk about with Aerospike doing the show is just a kind of background on scaling the heights of OLTP. It's, you know, I've watched the evolution of OLTP applications over something like 25 years now. And it's been kind of an interesting thing in a lot of ways, and it never occurred to me at any point in time that we would ever get to the kind of transaction rates that Aerospike demonstrates. You know, we used to talk in terms of 1,000 transactions per second being an extreme workload, and now we're talking in terms of 1 million. And that's really quite dramatic. So the point is really that what's been happening in the industry, particularly over the past 5 years, but it's really been the past 10 years, is that everything has started to scale. And, you know, if you step back to 10 years ago, you would never have been able to conceive of some of the applications that are being built now, whether we're talking about, you know, the big data analytics or the real-time analytics, or the kind of thing that Aerospike does, which is, you know, super fast transactions. there is, and Aerospike have demonstrated a need to scale OLTP to the highest level. So I was going to give some perspectives on this as a business perspective. In some systems, the optimal response time is 1/10 of a second, which is the human response time. Basically, that's about the time it takes for a baseball to leave the hand of the pitcher and arrive at the bat, the guy holding the bat. We can't respond any faster than that, but it does turn out. I mean, I immediately took note when Peter was presenting of this 10 milliseconds to serve an ad, and the human response time is 100 milliseconds. When Google originally did the evaluation of how fast should they make search go, they came up with 200 milliseconds. By doing various kinds of in-the-field testing, they started to realize that usage dropped off in a measurable way once the response times went out beyond 200 milliseconds. The reason that the ads need to have a faster response time than that is that 1/10 of a second is from the moment that the guy at the other end of the browser clicks, and there's a lot of other things that are going to go on before the advert gets served up. So the actual compression of time is extreme there, even though it's a human response time we're dealing with. But software can have higher expectations than that. Programs can need a much faster response times than that. And in some situations, which are market situations, there isn't a best response time that's defined in terms of time itself. The best response time is what makes you first. And what's kind of happened is that, while, the financial industry went from open outcry markets to actual real-time markets, and then you started to get this electronic trading. And then it became a matter of the speed at which you could make an order arrive at the market. And really, the best speed is faster than everybody else. There isn't a better speed than that. You're in the situation there when the transaction that you make changes the price in the market. And now with automated trading, they can pretty much work out how much profit there is in getting there first. And they will do whatever they can. They'll code in assembler language. They'll organize their machines to be closest to the market machines. They'll have the fastest communications and everything in order to be first. So in some situations, which are transaction processing situations, there is no limit to the speed that people may want. And there will continue to be a race, even when the latencies go down below where human beings can even, divine the meaning of those latencies. That's the business side. There's always going to be some kind of requirement for very fast transaction processing and very fast algorithmic analysis on the back of it. From a technology perspective, there's a number of things you can do. In-memory obviously makes you go way, way faster than you do with disk, but you've got to use the memory capability really intelligently. You've got to actually optimize it. And there's another point that I think Peter made, which is an important point, is you aren't just looking for a really good response time. You're looking for a consistent one. It's no good if in somewhere over the architecture you've got can actually get down to your target figure, which let's say might be 50 milliseconds, if it can't consistently do it, because in one way or another there are going to be some transactions that act on a lag where the owner of that transaction is going to be disappointed. So it's more difficult than just bringing the response time down. You've got to bring the response time down in line with the workload and try and deliver a consistent response across the board. This architecture is required for that, and it's not simple. You need intelligent parallelism. The problem with parallelism is as soon as you get off one box, you're on a network and you've got the network latency to actually deal with. So you basically don't want much traffic on the network. And I think that if you go through what Alvin was describing in terms of the way that the hashing works, you can see why the architecture of Aerospike is like it is. And a point which is clear in the Aerospike architecture, scales up rather than scales out. You don't scale out until you have to, because if you can remove as much traffic from messaging between servers, you're going to do better and better. You need accelerated SSD storage. The interesting thing about SSDs is that they're getting faster and faster anyway. What Aerospike has done, which I believe is unprecedented, is that they've gone and parallelized the SSD, and they've got a very slick way of indexing into the SSD. But all of it, in terms of the movement of hardware along the line, is going to make all of this kind of thing faster. And another point, it was almost, when Aerospike came out and declared themselves not SQL, it was almost, if you like, it probably raised a few hackles, because it had always been believed that OLTP was the province of SQL. When MongoDB started to undermine that, but the point is that SQL actually involves you in doing joins, are very expensive in terms of processing, and if you can avoid doing them at all, then you structure your data to do that if you're actually after extraordinarily high response times, which is again part of the Aerospike design principles, if I understand it. There always seems to be an advantage in going faster. It's like, as the time rolls by, we see hardware going faster and faster, and we suddenly got parallelism, and we're now living in we're migrating to a memory world, which has speeded up the processing of data in a dramatic way. And I suspect there's always going to be an advantage in going faster, whatever the application is. So this must have been about 6 years ago that I drew this diagram, which was just to demonstrate that as latencies came in, and this is a fairly complex graph in the sense that we're showing, the 1960s and the 1970s, 80s and 90s, and 2000, 2010. As the years go by, applications migrate from being slow to medium batch to fast batch. We still got what you would call fast batch applications going on in Hadoop, and then down to transactional level, then to interactional level with human response time taken into account, then to real time. And it seems that all the applications are going this way. This graph was drawn in 2010, and what happened after that was that the parallelism went extreme. So the acceleration in terms of the application migration went faster and faster. And I think that's what we're seeing with products like Aerospike that have extraordinary speed. We're seeing things, that are surfing on the wave of what's possible with the hardware and the software at this point in time, and it's caused a revolution in lots of ways. The SQL database is now a slow way of processing transactions because there's something much faster out there. And this is another point, but it's the final point. Parallelism increased the speed of application migration. So it drove applications down through that graph. But it started to become business process migration. And this is kind of interesting in some of the examples that Aerospike has come out with. The risk profiling in terms of knowing a financial position in multiple markets at the same time within a fraction of a second. That's not an application process, it's a business process that's going on. Fraud is a business process, and actually the placing of ads is a business process. I mean, Aerospike are only talking about their piece, but there's a whole set of pieces that come together to make ads possible in the way that they behave. So anyway, that's what I've got to say. I think you already answered the first question, Peter, but I'll ask it again anyway, just to see. I'm interested in the various things that are falling within your orbit. We're talking about very high OLTP applications, and okay, there's web advertising, there's automated trading, the telecoms was an obvious. Fraud and risk was a surprise to me. I never ran into it until, you know, I had a look at your deck this morning. Are there any other areas that are moving into this category?
Well, what we see from our customer base and the marketing we do is that we can't necessarily predict who needs to write more comprehensive algorithms, but once we realize that they do, it's very clear that we're the only database that supports them. So I'll give you maybe another customer example. We have another financial services customer. Unfortunately, we can't share the customer name, but you know it. And these guys had a real challenge where their legacy DB2 cache couldn't handle the load when they deployed mobile applications because the load exploded, right? You make an application more accessible and more usable, and all of a sudden you're going to have more people accessing and using it. So it wasn't necessarily an application, but they just needed a database that could handle that load. And they effectively used Aerospike as a cache to handle all that load, and it still runs with their back-end system of record. So that's another use case we didn't proactively go after, but turns out is a perfect workload for us. Let me hand it over to Alvin, and he's got a couple of use cases he'll share with you as well.
Yeah, I mean, I think one of the overarching trends is happening here is whilst you've got your data scientists and your BI teams who are looking at that historical data, and maybe they're using Hadoop or an equivalent to go crunch the data, increasingly you need to be able to take the results of those patterns and those trends you're finding and be able to make real-time decisions about that. You can't punt it off to a batch processing system. And so really I think the kind of intersection for me here is that is the intersection of essentially real-time analytics and blending that with the transactional information so you can act upon it in much more sophisticated ways. We first saw this in ad tech, and increasingly seeing it in telco and financial services. As Peter says, you know, new styles of application suddenly give you a need to have a greater access to your data and greater availability of that data than you ever needed previously.
Yeah, I can see that. And I mean, I think you're right. It's like we can call what you're doing OLTP, but it's OLTP with a lot of bells and whistles on it, in the sense that it isn't just a matter of registering transactions or capturing an event. It's a matter of responding to it in an extremely short period of time, possibly with, you know, reference to the data, and therefore it's kind of real-time analytics in a way. So
yeah,
the second question.
I think you're right, because it's all about creating a richer experience for the person at the other side of this. And generally, the richer experience, you need more context, you need more data to give them that experience.
Okay, the second question is just very simple. I looked at your slide deck this morning, and I was kind of thinking, this doesn't look like a cloud thing. This looks like you really ought to take care of how you're going to configure the hardware and connect it all up if you're going to run Aerospike on it. Would you agree with that?
I'll give you some feedback from what we see from our customers, and then I'll let Alvin talk to the ones and zeros. But if you recall early in my presentation, I said that 100% of our use cases are mission critical. What we still find is if it is a mission critical use case, most of our customers want to actually own the entire process. So we have some of our smaller customers using cloud-based solutions. A lot of our customers, not a lot, some of our customers host our database in usually AWS, but we have more cases where somebody ran a proof of concept or early days in AWS, and then when it was successful and their business started to grow, they took it in-house.
Okay.
Yeah, and I'd add to that, if you look at the trajectory of the cloud providers, increasingly they're creating more and more specialized offering. You know, EC2 back in the day was these really tiny slices of not very good servers. Increasingly, with the adding in specialist SSD drives or GPUs, the cloud providers are giving us, or the general public, access to architectures at very reasonable prices. That technology is going to play into our space because we have specifically optimized for those type of architectures. So I think the kind of long-term trend is that we potentially may see more deployments on those cloud type of architectures because the hardware, we're the type of software where very few can actually exploit that hardware to its fullest extent. And I think that's kind of, you know, the way that we see those architectures going.
Okay. Well, I mean, this is probably going to have to be my last question because I need to hand you on to Eric. But I'm interested in the range of applications. Commodity servers are not inexpensive when you actually have to assemble a lot of them and stick them in a data center and so on and so forth. You know, and you giving one cut have demonstrated that Aerospike can actually be extremely economical. So, I mean, it really kind of begs the question for me, well, obviously, if you really need very low response times, then Aerospike's something you should be looking at. But what's the range of applications where you might think to take a look at this technology? Because if you've got economy of the usage of hardware as well, then it's kind of like, it's kind of difficult to see from, you know, from the perspective you've given us so far.
So let me answer this two ways. One is you should look at Aerospike when you need speed at scale. That is our highest and best use. And in almost every instance where you're using speed at scale, we are significantly lower cost on the hardware side because of the way we do what we do. And Alvin walked you through the use of DRAM and the use of flash and the density of flash and the fewer servers that mandates. But you're asking a related question, which is, are there other use cases where maybe they're not as sophisticated as what we're used to, but where customers could benefit from a lower cost of hardware? And there are many scale-oriented use cases where the data sets are just so large that customers are using some other sort of key value store, and we solve the hardware problem very well with no compromise in software quality. So we see a fair amount of customers that have deployed something on a key value store. It's scaled, they've been successful, and then it's gotten really, really expensive. They come over to us. They don't necessarily need the performance, but they need cheaper scale, and we get that. We have a number of Cassandra migrations where people have been reasonably successful with Cassandra, but the cost is making it much more complex, and we can help with that.
That's interesting. Well, okay, Eric, I think you can take it away.
All right, I'll dive right in here. We got a good question regarding some of these credit-oriented issues. One of the attendees notes there's a problem in the industry. A single institutional client maintains a credit limit with many financial institutions, each of them different. However, nowhere is the credit limit aggregated across all these financial institutions and applied against each trade wherever it occurs. I mean, that's a situation out there in the real world. I guess you guys would try to solve that by trying to weave together some of these different scores that come through, or what can you say about that?
I'm sorry, let me make sure I understand the question. You're saying that if I'm an individual and I have 5 bank accounts or 5 brokerage accounts, is it possible to build one bank to build my risk profile based on data from 4 other banks?
Pretty much, yeah.
Yeah, I'm pretty sure that's not something we see out in the wild. That's more of like a credit scoring kind of thing where someone's going to aggregate all the data. But that's not what we're doing. What we're doing is, if you are, let's say you have your account with Schwab and you're trading every day and the markets are volatile and they're moving, notionally Schwab could build a risk algorithm based on you and all your assets, and they really only care about your dollars at their bank that are at risk. They don't care what's going on at another bank. You could have a enormous surplus at another bank or a big deficit at another bank, and it's not really relevant to the way Schwab works, because they couldn't go get that money from that other bank anyway. So we see it as pretty institution specific. So we've just not seen that use case come across our plate yet.
Yeah, that's fine. And you talked about this new generation of apps, and I think that's a really good focus area, because some of the new needs out there are going to simply need new applications built to serve them. One of the attendees is asking, where can we go to find some information about how to build these apps? What kind of resources do you offer or are out there in the real world for people to access to kind of wrap their heads around what needs to be built differently these days? How can you leverage a technology like what you guys are offering? What's the cookbook, if you will? Okay, I'm going to give you a very secret and highly confidential website that's going to solve all your problems. Ready? www.aerospike.com. And you've got an old-fashioned phone. We've got tons of use cases. We've got tons of developer materials, and we've got plenty of resources here where you can pick up a phone and call us, and we'll talk about what you're doing and work through your projects with you. So if you think you have a project that needs speed at scale, call us. We'll help you out. That sounds good. And this is a really good example. I'd like to kind of drill into this ad tech example, because with these use cases, there is so much pressure on a system like this to serve up data and to crunch the numbers. This is really an excellent example of why your architecture shines, right? I guess can either you or your colleague there kind of dive into why it is that you're able to handle this kind of scenario as opposed to other vendors?
Sure. I mean, it's really the way to think about this is, in order to optimize these flows, what you need is near line speed access to your data, i.e., you need to be able to get to the data as quickly as your packets are traveling down your network. And so essentially with the architecture in place, we eliminate the number of hops that you have to go to access your data. And therefore, with in this particular case, with a single access, I can go and grab, based on the cookie, the profile of the customer at the other end, and I've obtained all the information I can then actually use my algorithms to crunch on. And so to make that happen, you need extraordinarily quick and direct access based on a key to that particular set of data. And because we essentially blend DRAM and flash, you're not getting the penalties of having to go to a rotational disk in order to go get that data, but you're also not paying the penalties of a file system cache or an operating system cache in order to materialize that data from storage back into DRAM. And so that's kind of how we essentially take all the fat out of this, this transaction flow to give you the absolute minimum response time.
Okay, thanks, Alvin. That's a good answer. And we've got another really good question here that I bet you guys are going to love to answer. One of the attendees is asking, our firm is developing a global benchmarking application for the governance risk compliance marketplace. We're looking for an in-database analytics app that works with Google BigQuery. Should we consider your solution for this type of speed at scale?
Yeah, this is Peter. Not a whole lot of detail in the sentence, but I would say definitely you should look at us. As Alvin alluded to, what we often do is we will take a data set out of an analytics app like BigQuery and put it in the database so that the customer can write their algorithm, whatever application they need, and they can access that profile or that BigQuery extract and run a rules engine off that extract in real time. So we don't necessarily call that in-database analytics. We think of that as the application layer on top of the database. But BigQuery, much like Teradata, much like Cloudera or Hortonworks, is a natural technology partner for us because data sets that you create in those products very logically reside in Aerospike. Let me throw it over to Alvin for a little more color.
Yeah, and the key thing there is that we've got connectors that integrate with Hadoop and Spark, right? So it becomes very simple to have Aerospike as a source and a destination in the mix here in order to actually build this composite application.
Yeah, that's a really good point. And you're kind of speaking to this new era of possible architectures, and I think that's really part and parcel to what we're seeing out there in the marketplace these days. And as I look at this fraud detection or fraud prevention slide, I'm really glad you brought up this whole issue of false positives. I think everyone has come across one of these in the fairly recent past even, and they're very annoying. I mean, there's just no doubt about it. You're glad that your credit card company or bank is looking out for you, at least ostensibly, but nonetheless, when you get the false positive, it's very annoying. It can be quite upsetting. It can kind of throw off your day. So can you talk a bit more about how these new kinds of architectures can really be implemented to optimize fraud prevention without running into those false positives?
So let me just, I'm sorry, Eric. False positives are a problem for the bank. False negatives are a problem for the consumer. The false negative is you get a negative score, which means you can't charge.
Right, I'm sorry.
False positive is, right. So let me take a crack, and then let me throw it over to Alvin, who actually has degrees in this sort of thing. But again, the opportunity is to write an algorithm that encompasses as much data as you need to make an informed decision based on rules you build. And there are components of that that will be a profile, either created in Hadoop or BigQuery or wherever, and then there are other components that are live real time. And your algorithm runs rules quickly on Aerospike that leverage those data sets. So did I answer your question, or do we need to throw it over to the big gun?
Yeah, let's hear what Alvin has to say. Sure.
Yeah, I mean, the interesting thing in this particular example is the customer was using about 4,000 data points in order to make a decision. And they realized that with more sophisticated ways of perpetrating fraud, or more sophisticated ways they could actually understand that fraud wasn't occurring, they needed more and more data points in order to do that evaluation. So going from 4,000 to 8,000 rules, or data points, well, that's suddenly a doubling of traffic. And as a consequence, if you're talking about a doubling of traffic, let's say you have a cluster of 200 nodes to support this, now that's 400 nodes. 400 becomes 800 nodes. And so with a technology like Aerospike, where we can condense sort of 10 to 1 or more the infrastructure in order to support these types of analytics and queries, you suddenly have got the ability to actually deal with the scalability in a much more reasonable way than you can do on alternative architectures and technologies.
No, that's a really good point. And I threw this up here just as a last final slide to talk about a bit, because Robin made the great point. You only scale out if you have to, and obviously if you have only 14 servers versus 186, you've got a much simpler environment to deal with, and you save money, but you also are able to troubleshoot and streamline the processes, right? I mean, that's the beauty of having such a simple approach and not needing that many servers, is that you can get to the problem quickly and you can actually scale much faster, right?
Absolutely, and that's a key point about Aerospike, which is, we'll use the computing resources available. If you want to put more flash disks in or add more memory, we can scale up vertically and effectively utilize those resources. But clearly there's a cost associated with that. There's a different cost associated with going horizontally. If that's the route you want to go because that's the best TCO for your deployment, we can fully support that and fully exploit that hardware that's available. So we don't kind of force you down a particular path. You want to go vertical, that's great. You want to go horizontal, that's great too. You kind of need to know what makes sense for the terms of your application, the latencies you care about, and the cost of running that infrastructure.
Great point, folks. We burned through a little bit more than an hour here, but wanted to get to some of those good questions. You can see December Innovators, good slot for Aerospike. Next week we have Extra Hop as the final webcast of 2015. We're already booking shows for 2016, folks. So tell your friends, tell your neighbors, tell your colleagues to come check out the briefing room in the future. We do archive all these webcasts. Go to InsideAnalysis.com, look for the link that says Recent Episodes, and you'll find them there. And with that, we're going to bid you farewell, folks. Thanks again for your time and attention and for your great questions. We'll catch up to you next week. Until then, take care. Bye-bye.